Hi guys, welcome back to another coding challenge. Today what I've made is the game of Snake. So the classic game of Snake. You can see here that there's little bits of food that you can run and collect. In this version I've made it you're able to go through the walls. I know some versions when you touch the walls you die. In this one I decided to make it loop through the walls. And so yeah, we've made the game of Snake. Alright, so let's get into it. So I've got the blank processing sketch here, nothing much going on, just the setup and draw loop. So first thing we're going to do is set the size of the window. So I'm going to make it 1080 by 720, like that. So now if we run this, we should just get a blank screen. So there are a few things we need to think about for making Snake. So firstly, there's obviously the snake itself, moving the snake around, and then also the food that the snake's going to eat. So we'll start with the snake because I think that's the most important thing, being a game of Snake. So I'm going to start off by just getting one square moving around the screen. So I'm going to use a p vector and I'm going to call it pos for position, and I'm going to leave it not set to anything at the moment. And then in the setup I'll make it, okay, so we're going to reduce the screen into a grid, and so we'll need to have a size set for how big each square on the grid is. So I'll call this size, and I'll make it 20 for the moment. We'll see, we can change this easily later. And then we're also going to need the width and height of the grid. So this will be the width of the screen and the height of the screen divided by this size variable that we've just made. So call that W and H, and we'll need to calculate them down here in the setup. So width will be the width divided by size, and H will be height divided by size. And then we can say that the position will initially be the center of the grid. So that's W on 2 and H on 2, like that. So now if we go into the draw function and we say a rectangle at pos.x and pos.y, this won't be in the center of the screen because we've divided the width and height by the size. But so if we go pos.x times size and pos.y times size, and then the width and the height of this square will be size and size, like that. So if we run this, we should get a rectangle in the middle of the screen. So that's good. I might just quickly change the color of it and stuff. It's not really important, but style points, I guess. So I'm going to say no stroke, like that, and then I might say fill 0. So then we'll just get a black square in the middle. So that'll be our snake. So we're going to want to clear the background each loop as well. So we'll say, I don't know, background 200. Is that what the default is? I don't know. Yeah, that looks good. So gray background, black thing. So let's try and get this to move around the screen now. So we're going to have to use the key pressed function. So this is built into processing, and it will check for pressing keys on your keyboard. So what I'm going to do actually is I'm going to have a p vector called direction. Not set it to any, actually no, I'll set it to 0, 0 at the moment. So new p vector 0, 0. So what I'm going to use this for is to describe if it's moving, in which direction it's moving on the x and the y axis. So if the first one, if the x is 1, it'll move to the right. If x is -1, it'll move to the left. And then for the y variable, if it's 1, it'll move down, and if it's -1, it'll move up. So we're going to use this to control which way the snake is moving. So we're going to use the arrow keys for this, and to do the arrow keys we have to use the coded keys thing. So you have to check if key equals coded like this, and then you say if key code equals up. So if we're pressing the up arrow, then we want the direction vector to be a new p vector, and we want it to be 0, -1. So up, remember, -1 is moving up, and then we'll need to do this a bunch more times for down, left, and right. So down, left, and right. Why is it throwing an error? I need to use double equals. Alright, so if it's up, it's that. If it's down, it's that. And then for moving left and right, we don't want it to move up and down at all, so we set that one to 0, and then left is -1, right is 1. So now what we can do is in the draw loop, we can say pos.add direction. So what that will do is it'll add 1 to the snake's position each. Well, actually it'll add nothing at the moment, but when we press the arrow keys, it'll move it around the screen. So hopefully we can see that. It'll probably be moving quite quickly. Yeah, it moves very quickly because at the moment we're using the grid, which moves at 20 pixels for each grid square, which means it's moving at 20 pixels every update of the frame. So we're going to slow this down. We're going to use a speed variable, I think. So we'll have another integer, and we'll call it speed, and we'll say at the moment we can put that as 20 as well. These can all be tweaked later if it's badly wrong. But so what we can say is we say if frame count %0 % speed equals 0, then we'll update the movement. So what that's doing, this percentage symbol is modulo, so it essentially divides these and then looks at the remainder. So if the remainder is 0, if the frame count's divisible by 20, so every 20 frames, we'll be updating the position. So now if we run this, we should see that it moves a lot slower, and we can use the arrow keys to move it about. So we're going pretty well, I think, at the moment. So what we need to do now is we need to keep track of where the snake's been and use that to make the tail. So I'm going to do this in a way that perhaps isn't normal, I don't know. But I'm going to use an array list for the tail that's going to be separate from the head of the snake, because this will just make it easier when we're checking to see if the snake has run into itself. So if we keep the start of this snake a separate variable, it'll just probably simplify that a bit. I don't know if it'll actually help, but in my head it will. So we're going to create an array list of p vectors, and we're going to call this snake, and we're going to say it equals a new array list of p vectors, like that. So at the moment this is just an empty array. So we'll need to keep track of the length of the snake as well. So down here, int leng equals, I guess we could start it off at like 5 or something, don't know. So this is going to be tricky, because if we put them all on top of each other, then it'll collide with itself. I'll get into that later. So we're going to have to, I think if we do it in the draw loop, so when we're moving it, we can say snake, before we add the new movement to it, we'll go snake dot add. Oh no, not, is that it? Yeah, getting confused between p vectors and array list. So snake dot add, I guess new, can't spell, new p vector, and we're going to say pos.x, pos.y. So this seems kind of counterintuitive to make a new p-vector because the position's already a p-vector, but the way arrays work and stuff is they just store an address to the object that you're putting in it. So if we just add the position onto that snake vector, when you change the position variable, it'll also change in this snake array. So we got to like preserve it essentially. So we're going to add it like that, and then we also need to make sure that the snake doesn't get longer than the length that we've given it here. So we're going to say while snake dot size is greater than length, we're going to say snake dot remove snake dot size -1. So that'll remove the last one from the snake, I think, hopefully. And we close that off. So now we should see if we're moving, we don't get anything because we're not drawing the tail behind it. So we're also going to have to, I might move this to a new function called draw snake, like that. So then I'll go void draw snake, and we'll draw that, and then we'll also have to go in a for loop, int I equals 0, I is less than snake dot size I plus plus. So we're going to go through the entire tail of the snake, and we're going to draw a rectangle. So it'll be rect at snake dot get I dot x times size, and then we'll need to do it for the y, and then it'll be size and size. So we need to change that to a y, and then we should see, hopefully, that when we move around, we've got a tail that's not working properly. Oh, of course. So I've done something silly here. So when you add a new thing to an array list, it'll be the last thing, and I've been removing the last thing. So we actually want to remove the object at the start of the array. So now if we run this, we should see that the tail follows the snake. So we've got a snake moving around the screen. At the moment, you can go through yourself though, so we'll address that in just a second. Oh, another thing we should do is check if the snake goes off the edge of the screen, then it should wrap around back to the start. So down here, after we've added the position, what we're going to do is we're going to say if pos.x is less than 0, then pos.x equals the width -1, because if it's less than 0, yeah, okay, yeah, I think that makes sense. We'll have to check this when we run it. So then we're also going to do it, we'll need 4 of these. So, and then we need to check if pos.x is greater than width, and if it is, we'll make it equal to 0. This will be 0, and this will be height, and this will be height, and then we need to change these last ones all to pos.y. So this just checks if it's gone off the screen in any direction, hopefully. And then, oh, don't know what's, this doesn't look good. Okay, what have I done? Oh, this needs to be greater than. Oops. So now hopefully we should see if we go off the edge of the screen, it should come back around to the other side, hopefully. Yeah, so there we go, and we'll check the top as well. It's going pretty slowly, but that's right. Yeah, so it wraps around on the screen now, so that's good. That's really good. So last few things to do is add food and then check for collision against itself. So adding the food should be fairly simple. Actually, you know what? I might move all of this to an update snake function. So everything in here, I'm going to get that out of there just to make the draw loop not as cluttered. So we'll say update snake. I've already written all the code for it, so it's no dramas. So update snake, can't spell, like that. Copy, paste all that in, like that. And that should, oh, we need to move that back. So now it should run the exact same. So when we start, yeah, you can move around. All good. So, actually, you know what? I might change the head of the snake to be a slightly different color, just so it's a bit more obvious. So, okay, so food. We're going to have another p vector, and we're going to call it food. And then what we're going to do is in the setup, we're going to say food equals new p vector, and we're going to say random width and random height. So we're just going to we're going to put it on a random square on the grid. And actually, I'll need to make sure that these are integers. Oh, int. Like that. So, oh, I don't know why I ran it. Nothing's changed. So we need to actually draw the food onto the grid. So to do that, we're going to make a draw food function, and it's going to be very, very basic. So I'll put it above the snake stuff. So void draw food, and we'll take this, and we'll say fill. We'll make it red, and we'll say rect at food.x times size, food.y times size, size, like that. And that should be it, but I'll have to make sure that this goes back to 0, otherwise it'll be a red snake. Oh, and one more thing we'll have to do is do a new food function. So this will be for when the snake eats the food, we'll need to regenerate a position for it. So we've already done that in the setup function, so it's exactly the same. So now what we need to do, if we run this, we should see a random red square, yep. But at the moment, if we run into it, nothing's going to happen. It's just going to stay there. So what we're going to do is we're going to say in this update snake function, after we've added the position, we're going to say, I guess we'll say if pos.x equals food.x and pos.y equals food.y, then what we're going to have to do is we're going to say, we can do a number of things here. So we'll say new food firstly, so we'll generate a new food position, and then we're going to say length plus equals 1. So we're going to increase the length of the snake by 1, and then we're also going to say that the speed equals, we'll have to constrain this, speed minus 1, and we want to constrain it between, I think it's set to 20 at the moment, so between 0 and 20. So that should reduce the speed by 1, but then it won't let it go below 0. So if we run this, oh, the food's so far away. Actually, you know what I could do is I could increase this size, and it'll make everything faster. So if I grab the food, it got a little bit faster, and my snake is getting longer. So you can already see that it's working quite nicely. I guess the only thing now is to check for collision, because as you can see, I can go through myself and it doesn't kill me. So we'll have to fix that, and then we've got working snake. So to do the collision, we're just going to, okay, in the update snake, we'll have to do another for loop, which will be the same as this one for when we're drawing it. So we're going through all the snake tails, and we're going to check if pos.x equals snake.getI.x and we'll need to check the y as well. So we do all of that and check the y. Check y. Okay. So if that's true, then I guess we'll just create a reset function and you start again. So we'll make a reset function. Void reset. And this will essentially just set everything back to normal. So we'll have to copy all this, I guess. So speed is 20, length is 5. Speed equals 20, length equals 5. We'll have to reset the position to the middle again. So width on 2, height on 2. What else is there? I guess we'll generate a new food as well. Oh, and we'll clear the snake tail. So we'll say snake equals new array list p vector, like that. So that'll just clear it all so that we don't run into more collision issues. So one thing we're going to have happen is you'll notice whenever we're updating the snake, we're adding to the tail. But when we start initially, oh, that's another thing we'll have to reset. When we start initially, the direction is set to 0, 0. So you're not actually moving at all. So that means that the snake will be starting on its tail and not moving, so you'll instantly die. So what we'll have to do in the update snake thing is we'll say before we add to the tail, we'll make sure that we're not standing still, essentially. So if direction dot x does not equal 0, or direction dot y does not equal 0, then we'll add to the tail. And otherwise, we won't do anything. So hopefully, we should see that we can move around and eat some food and get bigger and faster. Oh, I'm not very good, not very good at this. And then if we run into ourselves, we reset and we start all over again. So we've made Snake in processing. So if you want to, you can download the code into the description. There'll be a link to the GitHub. I'm trying to multitask here, trying to play the game and say all the stuff. So yeah, GitHub in the description. There'll also be a link to processing, so that once you get the code from GitHub, you'll actually be able to run it and use it and play around with it. There's also a link to my website where you'll be able to vote on topics that you want to see in a future coding challenge. And if you'd like to, if you haven't already, please subscribe. It would be fantastic to have you along here for the ride. So thanks for watching, and I'll see you next time.